Good morning, sixth graders. Today is Wednesday, March 3rd, so it's a distance learning day for all of us. Today, what I would like you to do, as you can see from this slide, is to finish the interactivity about Earth's layers. Later in this video, I will help out with the last 4 questions, as I said I would yesterday, those of you that were in class. If you need help with the rest of it, Mr. Rocco's video does go through it very thoroughly. It is pretty long because he goes through the entire lab with you, so you can skip the parts that you don't need, or watch it in 1.5 speed if you want it to go quicker. But use that video because he does really do a very thorough job going through it and helping you out. Also today, if you are missing any assignments, please try and get caught up on those, especially if you're missing the severe weather public service announcement. I believe I got those entered into Infinite Campus yesterday, and so those grades should be showing up for you, but there were like 12 of you that still had not turned it in, so please make sure to get that finished up. That is counting the same as like a quiz. It's a 15-point summative assessment, so it's in the 80% category. Today I will have open office hours from 11 o'clock to 11:30 and from 12:30 to 3 o'clock. So if you need some help, or if you just want to pop on and ask a quick question about something, just join by entering the meeting code SEXTONOPEN and ask your question. I'll help you out with what you need, and then you can go. You don't need to stay the whole time. If that's not going to work for you, send me a Schoology message. I will be at my computer pretty much all day, so I will try and get back to you as soon as I can. So finishing up the interactivity, as I said. So I'm going to go over to Notability here. And so this is the assignment we're talking about, the worksheet that goes with the interactivity from the textbook. And so you should have copied and pasted in your data about the Earth's layers. And then we've got one graph about the temperature. So that's what all the red dots are representing as you were moving that elevator in the interactivity. We labeled the layers with the dotted lines. I didn't get mine quite finished labeling. If you look here, I should have written outer core and inner core here. Then we've got another graph that's showing us the pressure inside of the Earth. Notice that as we go deeper, the pressure increases, similar to the temperature, although there's a big jump in temperature right here. Did you notice that? So looking at these questions, yesterday, if you were in class, we talked about number 1 here. What are the states of matter for the outer core and inner core? And we've got those written on here. The outer core is liquid, the inner core is solid. And what data is going to help show us that? Well, we noticed that the temperatures level off. So it's not really going to be the temperatures that are causing that difference, but it is going to be the pressure. Because as the pressure increases, there's more pushing on all of the atoms and molecules, and if they are being compressed and compressed and compressed with all that pressure, that's what's going to make the inner core solid. And so this is the factor, the one I'm starring here, pressure. That is the reason why, or one of the reasons why, the inner core is solid and the outer core is not. For question 2, it says, using your graphs, how does the temperature of the Earth change as depth increases? So if you look at our graph here, how does the temperature change as we go deeper? Well, it is continuously rising, right? It starts lower down here between around 1700 or 1300, and then there's a big jump here, and then it just continues rising until it levels off just below 5,000. So we need to put that into words though. So I would say the temperature increases as the depth increases. Period. There is a larger increase between the lower mantle and the outer core. That was the one that we were looking at here in the graph. So that's going to be some help for you for number 2. Okay, it increases, but there's a bigger jump in between the lower mantle and the outer core. Question 3 says the deepest hole on Earth is only about 12 kilometers deep. So you should know that most of the data you collected in this virtual lab are actually scientific inferences, not actual facts. So that would be like some predictions that scientists have made based on the information they have. Do you think this information will change in your lifetime? Why or why not? So this is sort of an opinion question. First, yes or no. Do you think any of this information will change? The information we're talking about is measurements on pressure, temperature, the elements that are found. So yes or no, do you think any of that's going to change? And then why or why not? Do you think scientists will make some new discoveries in your lifetime? Or have scientists learned all that they're going to learn? Something to think about. I am thinking that it probably will change in your lifetime because scientists are continuously working to learn more about all parts of the world. The last question, this conclude question, do you think taking trips to the Earth's core will ever be possible? Use scientific reasoning along with the data you collected in this activity to support your response. So, based on what you know, do you think that that's going to be possible? And then, say why or why not. I mean, if I look at this, the thing that jumps out to me more is temperature, because I'm more familiar with temperature than I am with pressure. But these are some very, very warm temperatures. So do you think we would be able to withstand those temperatures of up to 4,500 degrees Celsius? Just to give you an idea, water boils at 100 degrees Celsius, and this is at 4,700. So do you think we would be able to go to the core? Yes or no, based on what you have learned so far about the layers of the Earth? Okay. Also think about, if there was going to be like some type of machine that you would be riding in, not a submarine, but like some type of subterranean, I suppose would be the word, vehicle. Think of the pressure that it would have to withstand going that deep. Do you think it would be possible for us to build something like that? So, that's a little bit of help for these questions. Do your best. Let me know your thoughts. A couple of these are kind of opinions. So, get those answers, and then please submit this today. Have a great day.